Okay, this is tutorial 1 for the equation of motion, and we have 600 Newton, 150 kg, and we need to find the reaction or the normal force on wheel A and also at wheel B. So how should we start? Definitely starting from the free body diagram. So let me sketch this diagram first. So this is the car. Okay, 600 Newton. And then our force. So I write it down there. And then from our gravity point, definitely will be our weight mg, 150 times the gravity, and the reaction. So at B and also at A. So this is the free body diagram. I have complete, no friction. Now, on the kinetic diagram, the movement of this car definitely will be on the x direction only. You see that? Because this car is moving forward. It doesn't move up. No. It doesn't rotate. No. So it only steadily moves to the x direction. So that's why our acceleration will only have an x. That will be our kinetic diagram. And free body diagram will be equal to the kinetic diagram, as we know. So we put it there and we write out the equation. Fx summation equals to max. Summation of Fy equals to May. I know what you are thinking, but just write it down. So summation of moment. So now I put a question mark there. It is talking about where it is your fixed point or your pinpoint of moment. It will equal to 0 if you are pinning on the gravity point, or we name it as G, because on the kinetic diagram, if you pin on G, so the max, that force will be eliminated. Okay, but if you pin on other point, then the force on the G will be calculated. So on our y direction, we know that the car is not moving or going up. If it's not going up, then our AY will be 0, and that will make the whole kinetic diagram on the y direction become 0. Okay, so right now, seems that we have all these things quite easy already. Just place the force to the respective direction. So on y, I will have my NB, my NA, and also my NG. So of course going up is positive and going down it is negative. So my NG going down, my NB and NA will be up. Okay, so for the summation of Fx, that definitely I only have one force on the x direction. So that will be pretty easy. So I just write 600 over here. So now you can see that on the x direction, that will be very fast or straightforward. I can get my Ax if you do a simple calculation over there. So I will get my Ax basically is 4 meter square. So I write the unit there. Alright, so I resolve the things. I got my Ax. If I look at my y direction, which is the NB, NA minus Mg, that equation, we cannot solve anything because NA and MB is unknown. Even though Mg we can calculate it quite easy. So if that will be the case, so I just move it over there, my mg. If I move it over there, then they become positive. So I will clear out a bit. With 0, definitely it doesn't mean anything, so I move a bit, and the 0 we can take it away and tie up our equation over here. Oops, never mind, just left the tail behind for the g. So I tie up my y direction mathematical expression. So if you want to write the number of the mg, you can write it down. That will be good. You can calculate the number. Okay, so now that cannot help us to resolve anything. So our only hope right now definitely will be the summation of moment. So I can pin at G, but let's try something more challenging to prove our understanding. So I'm going to pin at other point rather than G. I will choose A. So if I choose A, then the MAX cannot be neglected. So I will put just a moment unknown there first to represent that. So this is just an unknown. Okay, it doesn't mean that it is summation of MA. Okay, so this red color MA is just another unknown. Okay, be clear for that. Alright, so we are going to do this summation of moment pin at A, and that equals to definitely not 0. It will be something. We have to refer to our kinetic diagram. So look at the kinetic diagram. Our MAX that falls towards the fixed point or the pin point, which is A, that distance will be 1.25. So if you cannot remember that, so we'll take a look at the question diagram. 1.25, where is that? Okay, it's over there. So from the G to A, so 1.25. So in that case, my red color MA, so we can very fast to write it down. So M150, A is 4, AX is 4, that is what we have calculated already, and the distance 1.25. Why I'm putting negative over there? Okay, there's AX and there's our M. Okay, now the issue why I'm putting negative over there, because you look at the kinetic diagram, our force MAX will contribute my direction on what? Definitely it is on the clockwise. So but I want to put anti-clockwise as positive, that's my preference. So right now if MAX given me it is clockwise, so I put negative there. Okay, so now on my left hand side, I will write all the moment down. So I write it down and I explain that one by one to you through the free body diagram. Take notes for that. So on the left hand side, the moment that we want to calculate it is from the free body diagram. And on the right hand side, we are referring to the kinetic diagram. Okay, on the free body diagram, I'm writing down all the moment except at A, because the pinpoint at A, so all kind of force at A will be eliminated. So I write it down. So how all this come one by one? So let's start with that 150 and then times the 9.81. So you know that 150 times 9.81 is mg times the distance. That will be our first moment, or we call it m1. How we get that? Look at the free body diagram. So NA we eliminate because we put that as the pin point or fixed point. So MA towards mg towards A. So, and the distance will be 1.25. So now you know why just now is 150 times 9.81 times 1.25, because that will be our moment, and I denote that as m1. Take a look at the second one. 600 times 0.5. So 0.5 is the distance, 600 is the force. This is our m2. And how this come from? We take a look at the diagram again. So 600, that will be the P towards A. So the P, the distance towards A, definitely is 0.5. So that's why 600 times 0.5 as m2. And the last, that will be the NB times 2, which is the distance, and this is our M3. So look at our NB, that reaction force towards A, the distance. So NB, that will be 0.75 plus 1.25, that will be our M3. NB times 0.75 and then plus 1.25, the total distance, so that will be 2. So over here our M3, that's why we will write that NB times 2, and of course equals to that mathematical expression is what we got just now over there. So now take a look at this whole equation. We only have one unknown. Okay. Oh, so now that will be anti-clockwise for M1. M2 will be clockwise, and M3 will be clockwise as well. So that's why anti-clockwise is positive, clockwise is negative. So that given us that positive, negative symbol on our equation. So now, as I said, NP will be the only unknown in this mathematical expression. So we can do calculation very fast. Use the calculator, and NP given us a value of 1144.7 Newton. So don't make any silly mistake here, because simple calculation using calculator, we are not supposed to make mistake. So once we got our NB, then I will move it to my equation just now, the summation of Fy. So take a look at the NB plus NA, that equation. So my NB now I have a value. I can put that into that equation for my NB. Then definitely I will get my NA over there. Okay, so put my NB 1144.7. So now you see that this equation, I only have NA as an unknown, and I can easily calculate that. So NA will give me a value of 327 Newton. So by that, then I calculate and I solve this tutorial question. So by calculating all this according to the procedures.